Alright guys, so we're picking up where we left off on the volume of pyramids and cones note packet, and here we have a square pyramid again. Base, the edges are 10 by 10, and so the area of that base we know would be 10 times 10. And this is another one where your height is not drawn in for you. You've got to draw it in yourself, going down the middle and forming that right triangle. Okay, so then that gives you 13 on the hypotenuse. We know that since 10 is all the way across, then half of that would just be 5 for the base of the triangle. And this is actually a triple, but let's go see what the triple is. It's 5 squared plus height squared plus 13 equals 13 squared. So that's 25 plus height squared equals 169. We subtract 25 from both sides, and that comes out to 144. Square root both sides, and our height is 12. So that's the last thing we plug in, is that height. So we have 1/3 of 100 times 10 times 10, which is 100, times 12, which comes out to be 400 inches cubed. Okay, so I think we're ready to move on to the next shape, which is a cone. Cone is the same stinking formula as a pyramid. It's area of the base times the height, still 1/3. The only thing that's new is because the base of a cone is always going to be a circle, we just sometimes plug in pi r squared for the area of the base. That's the only thing new and exciting. And by the way, Cavalieri's principle applies to oblique pyramids and cones. So if we see some slanty cones like in part B, just keep in mind it's the same formula. The only thing that's more exciting is your height might be outside the cone. Okay, so here we go. Find the volume of each in terms of pi and also to the nearest whole number. You know what? Let's do this one in terms of pi, just because I'm afraid in Math Excel they might ask you for in terms of pi. And I think we've already practiced it to the nearest tenth or whatever. So here we go. Volume is 1/3 area of the base times height, and we know that that base is going to be a circle, so that's 1/3 pi r squared h. So in this case, it looks like that circle, the diameter is 10, and so the radius is 5. So we're going to say 1/3 times pi times 5 squared times our height is going up the middle, so that's 12. It's already there. So remember, when you do things in terms of pi, you multiply together all the numbers except for the pi, right? So in my calculator, I'm typing in 1 divided by 3 times 5 squared times 12, and that comes out to be 100. And so 100 pi inches cubed would be our answer in terms of pi. Okay, same idea here with part B. Volume is pi r squared h. So, I'm sorry, 1/3 pi r squared h. Not a cylinder, Miss Minton. So 1/3 pi, it looks like our diameter is 4, so our radius would be 2. And our height is 5.5. I'm going to write 5.5. So again, in your calculator, I'm entering 1 divided by 3 times 2 times 5.5. And that comes out to be 3.6 repeating. Remember, we don't put decimals with pi, so I'm going to math frac that in my calculator, and I get 11/3 pi inches cubed. So remember, the buttons you press to change a decimal to a fraction in your calculator is the math button, and then it's the first option under math. It's convert to fraction. It's a little arrow and it says frac. Alright, example 4. Find the volume to the nearest whole number. It's just reinforcing those oblique pyramids, right, are the same formula, same idea. 1/3 area of the base times height, so that's 1/3. Because this is 8 centimeters squared, excuse me, I know that it's referring to the area of the base and not just the edge. So this is my big B, friends, and this is my height, is the 18. So all I have to do is enter in 8 times 18, right? So that's 1 divided by 3 times 8 times 18. which is 48 centimeters cubed. Okay. So the last example we have, I believe, is find the volume of the variable in each figure. Leave your answer in simplest radical form. The diagrams are not to scale. Okay, so here we go. So volume is 1/3 area of the base times height. Since our base is a circle, I'm going to go ahead and plug in for this b, pi r squared times height, right? And then go to look at this picture, and it looks like x is our radius. Okay, so we said our radius was x. It looks like the height of the cone, the distance from the center to that vertex at the top, is the 6. And so we plug that in. That's 1/3 pi times x squared times 6. But we have one other piece of information here. We already know that the volume is 8 pi. Okay, so the only variable we have here is that x squared, and so we're going to go ahead and solve for that. So my first move is going to be to divide both sides by pi and get rid of the pi. So now I just have 8 equals 1/3 times x squared times 6. And keep in mind that order doesn't matter in multiplication, so if I would take 1/3 of 6, that's 2. So 2x squared, so I'm going to divide both sides by 2 to get x squared by itself. So that's 4 equals x squared. And so to get x by itself, I'm going to square root both sides. So x equals 2. Square root of 2 times 2 is 4. So your radius is 2. And it didn't give us units. Okay, so that's just 2 units. Alright, and then in part B, volume is 1/3 area of the base times height. So that's 1/3 times 15 times 15 times x. Our height this time we don't know. It's the x. And so, and then our volume this time they give us to be 1500. So I think what I'm going to do first is multiply this 1/3 times 15 in my calculator. And I get 75. So 1500 equals 75x. Divide both sides by 75. And x equals 20. 20 units again. Okay, so that's it for this video. I know it says, yeah, good. It says Math Excel because that is your homework for this section. So I will see you soon. Okay, bye.